gives me great pleasure to be joined by Vijay Nadendla, VP of Enterprise Data and Applications at Fortress Investment Group. Thank you very much for joining us.
Thank you.
Could you start off by just giving me a brief overview of what your role is at Fortress and tell me a bit about the key initiatives that you're working on right now?
I'm the head of Enterprise Analytic Platform and Strategy at Fortress Investment Group. We're currently working on a common data warehouse platform and its implementation across the entire company. We have a real-time data warehouse. We have data governance set up. We have scenarios management, what if analytic and Monte Carlo engines on top of it, and we're rolling it out to most of the company.
So now could you tell me what you think the biggest challenges are for data professionals in investment management right now?
For various reasons, I have heard structure, scale, need, speed, or agility. Investment banking firms tend to work in silos. And the problem with silos is that the IT operations also mirror those silos, but data doesn't. Data flows across those silos. And having a common data management strategy across those silos is a very, very hard thing to do. The other challenge that I see is Excel spreadsheets. We see that we are competing with Excel. Our users are very, very, very good in Excel, and they're able to do their work in Excel. Now, if we want to bring about a common analytics strategy and replace their work in Excel, it's going to be very difficult, convincing for them to do. And Excel has this versatility, simplicity, and familiarity that we need to bring into whatever we bring.
Okay, so what are you doing at Fortress to overcome the challenges with silos and Excel?
In Excel, we have from the beginning identified this problem. We need to outperform Excel or Excel as a spread mart in data storage and link spreadsheet part at least. So what we decided to do was deliver data straight to Excel at each point and let them use all the Excel functionality that they do. In addition, we allowed them to modify data and import back to the data warehouse from Excel. We put significant data governance on top of it, and we provided additional functionality that's not available in Excel, like creating your own hierarchies, name lists, scenarios, and standard calculations, and let them use Excel whenever they can and whenever we are unable to provide the functionality. So we built up the confidence based on the data governance that we have done. So the productivity gain is greater than the transition cost. And that's where we are able to get them move on to our platform. In addition, security is very important to get rid of silos. We made sure that we provide security for each data point individually. Confidence, security, that let us overcome these challenges.
So I suppose that links quite closely to big data and data warehousing, which I know you'll be speaking on at TSAM. Could you tell me what you think the biggest pros and cons are of big data?
Big data, everybody gives you these standard three letters, and which are the biggest pros: volume, velocity, variety, and I'll add in the fourth, which is the value. Big data has solved some of the problems that data warehousing is uneconomical, difficult, takes too long, or too hard to solve. When data volumes are simply too huge, it takes too long. Or when you need your reports very fast, when you need to analyze data very fast, at that time, that's the velocity. It's the rapidness of your response at that time. And when your variety of data sources is humongous, when you have unstructured data, or even when you have structured data, we have 100 different structures of data. Example, if we are looking at a mortgage servicing rights file, every mortgage servicer has its own format, and you're looking at 100 different formats that you get, and making a common analysis out of it, putting it into a data warehouse is going to be extremely hard. So big data has solved those problems. In addition, there is no value in building a data warehouse when all you need is 10 reports or one analysis. So when the scope of your problems space is very small, big data adds value, you don't have to build a data warehouse. Cons: confidence, canonical, concise. I'll explain. Let's start with canonical. Canonical is having a signal representation. A data warehouse represents data in one way. Big data means you are taking the data and putting it and storing it as is from the source formats. So in the case of before said example, you're going to store the 100 different formats that somebody needs to understand and analyze on the fly, and which means that this comes to the second point, which is confidence. How can I be confident that somebody has properly analyzed all these 100 files and come up with the right results? The best way to do this is, of course, having double blind, which is having two independent studies. That will immediately increase the cost. Even if you have two independent studies and you can find people who can independently come up with the same results, you will have to repeat this analysis for each and every time you use big data. So if you have 100 different problems to solve, and each one of those problems, you have to integrate the data, you have to standardize the data, then you have to understand the data. If you have to clean up or anything, you'll have to do all that all over again each time, which means immediately, I was here before, 20 years back, I remember grad students sitting doing particle physics, doing exactly the same thing. At that time, we were doing what is today big data, 500 gigabytes of data, trying to analyze and find a signal. But the problem at that point we faced is we don't have the data warehouses. We use big data, what we call as big data concepts. So we wrote humongous Fortran programs to analyze the data. And I can see the problems that arise there that will arise here too. When I moved from that to data warehousing, I was very relieved because it is like the 100 different analyses, you have an intermediate point that somebody analyzes and puts the data into. So every data analysis effort is 80% of data standardization, data study, data profiling, and 20% of analysis. So if somebody does the 80% and puts it at an intermediate spot, then you can do the rest 20%. And when you look at a big problem set, 1,000 different problems that you want to solve, this is a much better way of doing it. So to conclude, I would say that each has its own place. I would see, just like when multidimensional cubes came into this space, data warehousing incorporated them. So data warehousing is going to incorporate the big data concepts also and use them where it's relevant, where volume, velocity, variety, and value dictates that. But it's going to be a piece of the data warehousing. Maybe I'm wrong, but this is how I see it.
Okay, thank you. You've given me quite a thorough overview there of what you're working on and what the biggest challenges are. Do you have any final thoughts about data before I let you go?
Data warehousing, big data, data governance, master data management, all that we can talk about. It's not about the tools, it's not about the technology, it's about data. It's about how you understand the data, its context, its content, and your ability to be able to retrieve out trends and analysis out of the data, and to be able to come up with business insights out of your understanding of the data. And that requires people. And it is so, I would say big data, if you give the same person, same set of data scientists, ask them to build a data warehouse, they're going to build it to the same capability as a big data can. So it is more about the people, how the people understand data and use it. That is the data sense.
Okay, well, thank you again, Vijay. It's been very interesting, and I look forward to hearing more at TSAM.
Thank you.